Hello geometry students, this is Miss Latham, and I wanted to do some triangle congruence problems where they mix up all the different theorems and we have to figure out which one works. This is a lot like the quizzes that I sent you. So let's look at number 1. They've marked these pair of angles as being congruent. They also share this side, and remember the reflexive property, it's congruent to itself. So just look at the order that these things happen. You have an angle, this side, and another angle. So that's angle, side, angle. See how easy that is? Let's look at this other one. All right, we got these pair of sides and this pair of sides, and then they share this side. So again, look at the order, or look at what you got. We got a side, and a side. So that's going to be side, side, side. All right, let's look at the next one. We have these angles, we have these angles, and we have these sides. So you can either look at this as a side, an angle, and an angle, or an angle, and an angle, and a side. And when you look at this handy dandy paper that Miss Latham sent you, you can see that it's going to be angle, angle, side. All right, let's look at the next one. So we have an angle, we have a side, and then this, but I see right triangles. So I think of the theorem that deals with right triangles, and that's hypotenuse leg. They shared this longest side, which is their hypotenuse. So we have hypotenuse leg. Anytime you see right angles, you need to be thinking hypotenuse leg, but just check. All right, let's look at number 5. We have this pair of sides and this pair of sides. And we know, because of the vertical angle theorem, these angles are congruent. So this would either be side, side, angle, or the other way around, which makes not a nice word. So when I look on my paper, there is no side, side, angle. So guess what? They're not congruent. They may be, but I can't say that they are based off what I have. All right, let's look at number 6. For number 6, these are parallel lines. They're also congruent sides. We have these angles are congruent, and since these are parallel lines, I know that these two angles are also congruent. So we have an angle and a side and an angle. So it's going to be angle, side, angle. You getting the hang of this? All right, let's look over here. They share a side. They give us these sides and these angles. So I'm going to mark the side that they share, go in the order that they happen. Side, angle, side. Side, angle, side. This stuff is awesome. All right, let's look over here. Pair of sides, share a side. I see side, side, side. Side, side, side. All right, let's look at the next one. Alrighty then. I see right angles. So I'm thinking, let's see if it could be hypotenuse leg or HL. Here's the hypotenuse, congruent, congruent. Here is a leg, congruent, congruent. Hypotenuse leg. Yeah, baby. All right, let's look at number 10. For number 10, we have an angle and a side. And let's go ahead and mark up those vertical angles. So we have an angle, and a side. So that's going to be angle, angle, side. Last two of these. All right, we got an angle, and they share a side. But I don't know anything else. So guess what? Not enough information. Not congruent. All right, and then for number 12, we got some more parallel lines, which happen to also be congruent segments. These are congruent segments. We have these angles are congruent because they're vertical angles, but we also have these angles are congruent because they're alternate interior angles. And you know what else? These angles are actually also congruent for that very same reason. So we got 3 pairs of congruent angles. So you got a couple options here. You could go with angle, side, angle. Or you could go with side, angle, side. How about that? All right, I want to do a few more proofs with you, and then we're going to call it a day. All right, it says, and this is the paper that says Mixed Practice Proving Triangles Are Congruent. So let's write down our first given, and that is L is the midpoint of KN and MP. So L is the midpoint of KN. So I know that this is congruent to this, and I'm going to have to write that down here. And I know that this is congruent to this because it's also the midpoint of MP. So let's say what we know. I know that KL is got to be congruent to LN. And that's the definition of a midpoint. I also know that ML is congruent to LP. And again, definition of midpoint. What else do we know? I think we got a congruent angle. Do you know what angles are congruent? This one and this one. So I can say angle MLK is congruent to angle PLN. And why are they congruent? What is their special relationship? They are vertical angles. All right, we got a side, we got an angle, we got a side. So I can say what I'm trying to prove here. Triangle MKL is congruent to triangle PNL, and that is by the side angle side theorem. Sweet. All right, let's look at the next one. All right, it starts off by telling us that BD bisects angle ABC. So here's BD. It bisects angle ABC. So that means I know that this angle right here has to be congruent to that angle right there. So I'm going to say angle ABD has got to be congruent to angle CBD. And how do I know that? By the definition of an angle bisector. All right, let's see what else they gave us. They got that angle BAD is congruent to angle BCD. And that is given. So let's mark that up. BAD, boom. And BCD, boom. All right, what else do we know? Well, they share this side, so it's definitely congruent to itself. So I can say BD is congruent to BD, and that is by the reflexive property. So why can I say triangle ABD is congruent to triangle CBD? Anybody? That's right, by the angle side theorem. All right, one more. Let's use pink. All right, it gives us that S is the midpoint of QU. So let's find that over here. Here's S. Here's QU. If this is the midpoint, what do we know? I know that this has to be the same length as this because that's the middle. So I can say that QS is congruent to SU. And how do I know that? By the definition of a midpoint. All right, what else did they give us? They've got QR is congruent to ST. So QR is congruent to ST. Let's mark that up. QR, boom, boom. ST, boom, boom. That is given. And they gave us something else. They're so generous. RS is congruent to TU. So RS, boom, boom, boom. TU, boom, boom, boom. Given. So I got this. I can say triangle QRS is totally congruent to triangle STU. How do we know this? What theorem can I use? And the answer is side, side, side. See? Side, side, side. You guys got this. I miss you. Have a good day.